Hello and welcome to another class on periodic properties and periodic classification. We are almost at the end of our program, periodic classification program. We were discussing the periodic property electronegativity, EN, and we know that it is a relative quantity is expressed by a numerical having no unit, and the maximum electronegativity is that of fluorine, 4, approximately 4. We take it as 4. This is the most electronegative element, although it is the second most element having the highest electron affinity. Highest is chlorine, the second highest is that of fluorine. So far as electron accepting is concerned in the gaseous state, it is second highest. But so far as in a covalent bond, polar covalent bond with a different atom, so far as its tendency to attract the shared pair or the bond pair is concerned, it is number one. So the polarity wise, it is highest in any supposing HF bond. We shall be learning about all these. I told you that HF is much more is more polar than HCl. And I also told you when the electronegativity difference is 1.7 or greater, then the bond will be predominantly ionic. Of course, having some covalent character, some sharing character. We will see how it will affect the properties of such compounds. And if it is lower than 1.7, then we call it predominantly covalent, but still having ionic character as long as delta En does not vanish. As you find delta En becomes lesser and lesser, smaller and smaller than 1.7, the electronegativity decreases, and the difference decreases, I'm sorry, then you will find the bond becomes less and less polar, the ionic character becomes less and less until the two are identical, or coincidentally their electronegativity values are same. In that case, it is a pure covalent bond, a non-polar covalent bond having no ionic or polar character, like N triple bond N, O double bond O, Cl. These are having no polarity, and they're pure covalent bonds having no ionic character. And also we know in a period usually, and let me show you that particular file, the data, and just remind you before we. And the second highest is that of oxygen, third highest is bromine 2.9, and if it is less than 2 or around 2 or less, then it will be a metal. Hydrogen is 2.2, and more than 2 or 2.2 is non-metal. Chlorine and nitrogen enjoy the third highest, approximately 3. CGM has the lowest one, 0.79. And these things we already know. In a period, it increases as the metallic character decreases and non-metallic character increases. Down the group, the opposite. We know that. We all know that if you look to the middle group, you find instead of decreasing, it is increasing. Gallium has a greater electronegativity than aluminium. So also germanium has a greater electronegativity than silicon. But here, after gallium and germanium is a this germanium is a semi-metal or a metalloid, and silicon is a metalloid, boron is a metalloid. Gallium is not a metalloid, so it's a metal. Now you find that only in arsenic it is slightly lower, slightly lower, they're almost same. only you find a little bit difference in between chlorine and bromine. And you find sulfur, selenium, they are mostly similar, same, almost same, but there is a very drastic increase, detectable, appreciable increase from aluminum. This is due to the middle row anomaly because of the D block or scandide contraction, then the electronegativity is more. We also found that the ionization enthalpy is also more than expected, so much so that gallium was having greater than aluminum. So all properties will be unique for these elements because of the middle row anomaly. We have seen all this discussion we have made. And helium, neon, argon, they do not, I mean, not the electronegativity have not been found out because we need to have a concrete covalent bond. Then only we can find argon with someone. Krypton, yes, 3. Xenon is 2.6. Radon is radioactive, not found. Now, we have also seen how it goes on decreasing, and then suddenly it is the lowest. It goes on increasing, I'm sorry, and suddenly it becomes, because the neon has no data, suddenly it becomes the lowest and the next alkali metal, which is little lower than the previous alkali metal. These things we know, we have discussed. Now we shall be doing how to determine the electronegativity, determination of electronegativity. One is Pauling scale. Pauling scale is based on, you know, experimental data, so that supposing this is delta En, they used to write delta xi, so I make it delta En, which is equal to electronegativity of an element A and electronegativity of element B, out of which we shall take one of them as a reference. A reference can be hydrogen, and this delta En is equal to 0.208, that is the empirical relationship that they found, root over I'm writing BE, bond energy, AB. I will be explaining you in the details, minus BEAA plus BEBB by 2. This is the arithmetic average, square root. Or they also can use the geometric average. Geometric average you can use instead of using bond energy AB minus, you can multiply them. Oh, sorry. You can multiply them and take a square root. Of course, you have to take a square root again. BEAA into BEBB. Any formula you can use, this is the geometric mean or average, and this one is the arithmetic average. Usually we use this first one. Now let me tell you what is AB. BEAB is the bond energy. The bond energy, particularly in kilocalories per mole, that you have to see. Otherwise, you convert between the two, A and B. You have to take a compound in which there is a bond between A and B, covalent bond, and you have to break that bond and see how much of energy is spent out. That is called the bond energy. the amount of energy needed to break the bond of a particular type, maybe 1 mole of bonds of a particular type in the gaseous state. In the gas, that is the definition of bond energy. We'll be doing that in our thermodynamics program. And definitely BE, bond energy AA, will be bond energy in kilocalories per mole between A and A. OO, single bond. I repeat, it is should be single bond. O single bond O. There are many. Hydrogen peroxide has OO single bond. And nitrogen single bond, there is an hydrazine, it is NN single bond. So you can get single bonds between identical atoms and break them and find that energy. And similarly, BB. And take its mean, better arithmetic mean. So this difference is due to this difference between the actual bond energy between A and B and the average bond energy between the two AA and BB. It is due to the polarity factor, the difference in electronegativity, ionic character factor. So Pauling related this difference in electronegativity to this extra bond energy. This portion, this entire portion is called the extra bond energy. They used to call it. Why there is a difference? Why there is a difference? Why actual AB bond energy is greater than the average between the two AA and BB? It is because of the polar nature, because the electronegativities are not same, because of the ionic nature. So he could find a relationship by hit and trial method, and that is called the empirical relationship. And we will find a problem. You use, supposing I will give you this problem now to find out the bond energy between HH ଦେଇଛି, FF ଦେଇଛି, and HF ଦେଇଛି. AA, BB, and AB ଦେଇଛି. Calculate the electronegativity of fluorine according to Pauling scale. And one of them has to be a standard reference. Hydrogen is given to be 2.2. So electronegativity of nitrogen, sorry, fluorine minus electronegativity of hydrogen is equal to 0.208 root over bond energy HF minus, let us take the average of this. So bond energy HH plus bond energy FF by 2. In geometric mean, you have to take a root, multiply, then take root. But in arithmetic average, just simply add and divided by the number, total number of items, 2. So this you have to find out. Supposing this is x and this is 2.2, this is the reference that you have to take, 0.208. And if there is no unit is not kilocalories per mole, then you have to convert. It is given. So this HF is 135.9 minus 104.2 plus 37.8 by 2. Take the square root. So this, find out what is x.
3.98.
Huh?
3.98.
Precisely correct. କେତେ ବାହାରିଲା ସ୍ୱୟଂ?
Again, sir, 3.97.
97 or 98 whatever ଏକା କଥା, which is ଆମେ approximately 4 ନଉ, and ଆଉ ଗୋଟେ ସ୍କେଲ ଚେଞ୍ଜ କଲେ ଏଟା ପଲିଂ ସ୍କେଲରେ, then ଆଗରୁ ଯୋଉ ସ୍କେଲ ଥିଲା, let me tell you the other scale which was Mulliken scale. Did you understand this scale properly? अरे
Again, sir.
ବୁଝିଲ କି ନାଇଁ?
Yes, sir.
Yes, sir.
Mulliken scale ଟା ଆଗରୁ ଥିଲା, এইଟା इलेक्ट्रोनेगेटिविटी बाहर केमती से एमती जाए दौले इलेक्ट्रोनेगेटिविटी इज इक्वल टू आयोनाइजेशन एंथैल्पी मीन्स फास्ट आयोनाइजेशन एंथैल्पी प्लस फर्स्ट इलेक्ट्रॉन एफिनिटी न्यूमेरिकल टर्मटा बाय 2 ये किंतु मैच कला नहीं क्या संगे मैच कला नहीं दिस वाज फाउंड टू बी इनवैलिड डिड नॉट मैच विथ द मॉलिकन स्केल से करेक्टेड है कौन ना En इज इक्वल टू गोटे फैक्टर এইটা ହିଁ ୟୁଜ୍ କଲେ ପାଖାପାଖି ଆସିବ, ଏଇଠି ଗୋଟେ 2.28 ଫ୍ୟାକ୍ଟର ଗୁଣିବାକୁ ପଡ଼ିବ ଏଠି, ସୋ এইটা ଯଦି ୟୁଜ୍ କରିବ ପ୍ଲସ୍ EA ବାଇ 5.6 ୟୁଜ୍ କଲେ ଯାଇ ହେବ, କିନ୍ତୁ ଅଲ୍ ଏନର୍ଜି ଇନ୍ ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟ ତାର ଯେମିତି କିଲୋ କ୍ୟାଲୋରିଜ୍ ପର ମୋଲ୍, ଏଇ ମଲିକେନ୍ ସ୍କେଲରେ ଏଇଟା ହେଉଛି ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟରେ ପ୍ରକାଶ କରିବାକୁ ପଡ଼ିବ। ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟ ମାନେ ପର ଆଟମ୍, ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟ ପର ମୋଲ୍ ନଥାଏ। ତେଣୁ ଆମକୁ ଯଦି ଗୋଟେ ଅଙ୍କ ଦେବି ତମେ ଦେଖିବ ସେଇଟା ତାକୁ ଆଉ ଆଜିକାଲି କେହି ତାକୁ ୟୁଜ୍ କରୁନାହାନ୍ତି, ଇଟ୍ ହାଜ୍ ବିନ୍ ଅବସୋଲିଟ୍, ବଟ୍ କେତେ ଏଇଟା ବହୁତ ଆଗରୁ ଥିଲା। ଚେଷ୍ଟା କଲେ ମଲିକେନ୍ କରିବା ପାଇଁ ଗୋଟେ ସ୍କେଲ ମିଶିଲାନି, ଏଇଠି IE and EA of fluorine is 17.42 electron volt and 3.45 electron volt respectively. Electron चुमुटिकी बाहर करिया it takes a lot of energy for electronegative element which rather loves to devour electron and release energy, and yes, it releases 3.45 electron volt energy per atom. So find the electronegativity of fluorine in absolute Mulliken scale and trans absolute बाहर करिया दरकार नहीं, ए बहुत कम बाहर बाई 2 करदेले बहुत कम बाहर এটা করনি, এটা ছাড় দিও। কিন্তু ट्रांसफॉर्म्ड मॉलिक्यूल स्केल एटाको कहते ट्रांसफॉर्म्ड मॉलिक्यूल्स, करेक्टेड जाको मु कहूची से माने कहते ट्रांसफॉर्म्ड, जोटा टिके मैच करिवो। सो सिंपली इलेक्ट्रोनेगेटिविटी ऑफ फ्लोरीन इज इक्वल टू 17.42 प्लस 3.45 बाय 5.6 नहले हबनी 2.8 हेले
3.7.
केते
3.7.
Sir, 3.73.
के तथापि मध्य मैच कलानी, आउ जदि खाली 2 होइथांता आउरी अधिक आइथांता, 2 होइथांता आउरी अधिक आइथांता, यू नो आउरी अधिक आइथांता 10 मु देखुଥିଲି 10.43 खाली जदि 2 करथांतो ओरिजिनल ये, तेणु सेथिपई ट्रांसफॉर्म करागला, बट ताठू बेटर सबुठू वर्तमान आलरेड एंड रोको बहुत मॉडिफाइड मेथड बाहर लानी। Allred and Rochow scale is very dependable. So here electronegativity जाको सोने जाए कहूले is equal to गोटे constant factor अच्छी 0.744 plus 0. Out a constant factor 359 into effective nuclear charge Z star. You have to find out using Slater's theory and then R square. এই ইকুয়েশনটাକୁ ସେମାନେ ୟୁଜ୍ କରନ୍ତି। So where Z star is the ENC, effective nuclear charge, determined from Slater's rule, because you have to determine sigma first using Slater's rule, determined from Slater's, and R is the covalent radius because we know all elements have now covalent radius. Even if they are metals, they have been corrected for covalent radius. Covalent radius in angstrom unit, directly you have to use in angstrom unit. You will not use any angstrom here, but the data that you will be using should be converted to or given in angstrom unit. So this is a better scale, and if we can solve this problem, it will be calculate the electronegativity of silicon. Atomic number is 14, having covalent radius 1.175 angstrom. So we have to find sigma first. For sigma, 1s2, 2s2, 2p2, 2p6, 3s2, 3p2 is carbon family 1 plus 1. So in the same, since we are finding the screening effect for S or P, this is P electron, then the rule says that sigma is equal to 0.35 into 3. We have to leave one electron as the outermost electron, plus this is n minus 1 is 8 into 0.85 plus n minus 2, n minus 3, n minus 3. So 2 into 1. How much?
So 9.85.
9.85.
So if this is sigma, so Z star is equal to 14 minus 9.85. कितने?
So 4.15.
4.15 is the effective nuclear charge. Then use this in the Allred Rochow equation, that En or Xi is equal to 0.744 plus 0.359 into Z star जगह हमें पकड़ा 4.15 by 1.175 plus square. Eta
1.82.
1.82. So, yes, if you look to the table, you'll find we don't know which scale. I think these all of them are based on the Pauling scale. If you look to the data, silicon is giving 1.9. हमें कितने बाहरला 1.82.
82.
82.
It's very close. ମୁଁ ଦେଇଛି 1.9. ହଁ 1.9 ଏଗୁଡ଼ା ସବୁ ପଲିଂ ସ୍କେଲରେ ଦେଇଛି, ପଲିଂ ସ୍କେଲ 1.9. ତ ଆମେ ଆଲରେଡ୍ ରୋକୋ ସ୍କେଲରେ ବାହାରିବ, ଟିକେ 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 ଡିଫରେନ୍ସ ଆସିବ if the scales are different. And later, and this will be the end of our program, later there are so many other scales developed, like Sanderson scale, Allen scale, Mulliken scale. We are not interested, but this you have to remember. Have you written this? Ionic fraction in a polar covalent bond. गोटे approximately बाहर करिया पई तार अलगा मेथड भी अछि केमिकल बॉन्ड रे पढिबा हमें from the dipole moment study, but this is another not very crude but a crude method to find out the percentage of ionic character or polar character in a covalent bond. That is called ionic fraction, is 1 minus e to the power minus 0.25 into electronegativity difference square of the electronegativity difference. Got it? लिखिलो
Yes, sir. Yes, sir.
ये मेथड रे e ର value, e is the Euler constant, 2.718. E is the Euler's number or Euler constant. So supposing ମୁଁ କହିବି ମୁଁ ଗୋଟେ ଅଙ୍କ କରୁଛି, ଏଟା ଗୋଟେ just write down. କରିକି ମୁଁ ଗୋଟେ ପଚାରିବି HCl ରେ ବାହାର କର approximately the percentage of ionic character or polar character ଯେତିକି fraction ବାହାରିବ 100 ରେ multiply କରିବ ଆଉ H ହେଉଛି 2.2 ଦେଇଥିବ ଧର କ୍ଲୋରିନ୍ ଦେଇଛି 3 approximately ସବୁ so difference ଜାଣିଗଲ so how to get it 1 plus e to the power x can be expressed as a infinite Taylor series 1 plus x by 1 plus x square by factorial 2 x cube by factorial 3 and so on ଆମର ଏତେଟା ଟର୍ମ ଦରକାର ନାହିଁ ମାଇନସ୍ ଥିଲେ ମାଇନସ୍ ଆସିବ ଏଇ ଯଦି ଟେଲର ସିରିଜଟା ଆମେ ୟୁଜ୍ କରିବା ଏଠି ଦେଖ ଏ ଆୟନିକ୍ ଫ୍ରାକ୍ସନ୍ ଇଜ୍ ଇକ୍ୱାଲ୍ ଟୁ 1 ମାଇନସ୍ ଅଛି ଏଠି ଥାଉ ଏଇଠି ଗୋଟେ କରିଦେବା ଇ ଟୁ ଦି ପାୱାର ଇ ମାନେ 2 ପଏଣ୍ଟ କେତେ
2.71828.
2.718.
8 ଟୁ ଦି ପାୱାର ଏଇଠି ଗୋଟେ ପୁଣି 1 ଅଛି 1 ପ୍ଲସ୍ ଏତିକି ଏଠି କରିଛି
Sir, 18.1.
रो ଟିକେ ରହିଥାଅ ଏଇଟା ଆଗ ଇ ଥାଉ ଏଇଟା ବୋଧେ କୋଉଠି ମୁଁ ଏଇଟା କରି ଛାଡ଼ି ଦେଇଛି ବଟ୍ ମୁଁ ବତେଇଦେବି ବର୍ତ୍ତମାନ ଏଇଟା ଇ ବର୍ତ୍ତମାନ ଥାଉ ତାପରେ ଦେଖିବା କେତେ ହେଲା ଆଗ ଇ ଟୁ ଦି ପାୱାର ଯୋଉ କନଷ୍ଟାଣ୍ଟଟା ଦେଇଛି minus 0.25 into what is the electronegativity difference 3 minus 2.2 କେତେ
0.8.
ତ କେତେ ହେଲା ତାହେଲେ 1
0.8.
minus e to the power ମାଇନସ୍ କେତେ ହେଲା 25 ଟା 200 କେତେ
-0.2.
Minus 10.
ଏତିକି ହେଲା ଆରେ ହଁ କି ନାହିଁ ମୁଁ
Yeah.
so if you look to uh, one plus x ଆଉ ଇ ରହିବନି ମୁଁ ଇ ଭୁଲରେ ଲେଖୁଥିଲି 1 ପ୍ଲସ୍ ଏକ୍ସ ପ୍ଲସ୍ ଇ ଟୁ ଦି ପାୱାର ଏକ୍ସ ର ଏକ୍ସପାନସନ୍ କ'ଣ ହବ ଇନଫାଇନାଇଟ୍ ସିରିଜ 1 ପ୍ଲସ୍ ଏକ୍ସ ଏକ୍ସ ସ୍କୋୟାର ଠିକ୍ ଲେଖିଥିଲି ମୁଁ ଠିକ୍ ଲେଖିଥିଲି ସୋ ଏଇଟା ଯଦି ଆସିବା ଆମେ ଆର ଭ୍ୟାଲ୍ୟୁ ହବ ଏଇଟା ତ 1 ରହିଲା ମାଇନସ୍ ରହିଲା ୟାର ରହିଲା 1 ପ୍ଲସ୍ ଜାଗାରେ ଏଠି ମାଇନସ୍ ହବ ଏକ୍ସଟା ମାଇନସ୍ ଅଛି ସୋ ମାଇନସ୍ 0.2 ବାଇ 1 এটা স্কোয়ার হয়ে গেল 0.2 ର ସ୍କୋୟାର କେତେ 2 ଦୁଗୁଣେ 4 0.04 ବାଇ ଫ୍ୟାକ୍ଟୋରିଆଲ 2 ମାନେ ସେ 2 ତାପରେ ଟର୍ମ ଗୁଡ଼ା କିଛି ନାହିଁ ମାଇନସ୍ 0.2 ର କ୍ୟୁ 2 ଦୁଗୁଣେ 4 ଦୁଗୁଣେ 8 କେତେ ହବ
0.008.
ବାଇ ଫ୍ୟାକ୍ଟୋରିଆଲ 3 ହେଉଛି 6 ଏଇଗୁଡ଼ାକ ଦରକାର ହୁଏନି ଏତେ ନେଗ୍ଲେକ୍ଟ କରି ଏଇ ମ୍ୟାକ୍ସିମମ୍ ଦୁଇଟା ଟର୍ମ ଆମେ ଦେବା ଏଠି 1 1 କଟିଗଲା ଏଠି ପ୍ଲସ୍ ଆସିଗଲା 0.2 ଧରି ଏଇଟାକୁ ନବା ବି এই ଟର୍ମଟାକୁ ନବା ନେଲେ ନେଲେ କେତେ ଆସୁଛି ମାଇନସ୍ ହେଉଛି ଏଠି ମାଇନସ୍ ଅଛି ଏଠି ମାଇନସ୍ ଆସୁଛି କେତେ ଆସୁଛି ନିଅ 0.02 ହଁ କି ନାହିଁ
ଆଜ୍ଞା ସାର୍
ତାହେଲେ ପଏଣ୍ଟ କେତେ ଆସିଲା ଏ ଟର୍ମଟା ଆହୁରି କମିଯିବ 1.8 ତାହେଲେ ଆୟନିକ ଫ୍ରାକ୍ସନ ହେଲା 0.18 ତା ମାନେ 18% HCl ବଣ୍ଡରେ ଯୋଉ polar character ଅଛି ବା ionic character ଅଛି because of the electronegativity difference is only 18%. Remaining 82% is ionic. 82% is covalent and only 18% is ionic. You understood?
ଆଜ୍ଞା ସାର୍
ୟେସ୍ ସାର୍
ଏଇଟାକୁ ନେଇଥିଲେ ଆଉଟ୍ ଫୋର୍ଥ ଟର୍ମ ନେଇଥିଲେ ଆର ଏଫେକ୍ଟ କିଛି ନାହିଁ ମ୍ୟାକ୍ସିମମ୍ 3ଟା ଟର୍ମ ନେଲେ ଚଳିବ ଦେଖିବ ଆମେ ଯେତେବେଳେ ପୋଲାରିଟି ପଢିବା ଡାଇପୋଲ ମୋମେଣ୍ଟ ଭ୍ୟାଲ୍ୟୁଜରୁ ବାହାର କରିବା ଆଠୁ ବେଟର ଆକ୍ଚୁଆଲି 16 ପଏଣ୍ଟ ସମଥିଙ୍ଗ ବାହାରିବ ଏଇଟା ଗୋଟେ କ୍ରୁଡ୍ ମେଥଡ ତା ଛଡ଼ା ବି ଇଲେକ୍ଟ୍ରୋନେଗେଟିଭିଟି ଠିକ୍ ସେ ଆମେ ଦେଇନେ କ୍ଲୋରିନ୍ର ଏକ୍ଜାକ୍ଟଲି 3 ନୁହେଁ କ୍ଲୋରିନ୍ର ଯଦି ଦେଖିବା ଡେଟା କୌଣସି ଜାଗାରେ ତମେ ଏକ୍ଜାକ୍ଟ ଆମେ ନେଇଯାଉଛେ 3 ମାନେ କମ୍ପାରିଜନ କରିବା ପାଇଁ ବଟ୍ ଇଫ୍ ୟୁ ଲୁକ୍ ଟୁ ପଲିଂ ସ୍କେଲ ମୋର 3 ମୁଁ ଦେଇଛି 3 ରାଉଣ୍ଡ ଅଫ୍ କରିକି ଏମାନେ ଦେଇଛନ୍ତି 3.04 ଆଉ ଗୋଟେ ପଲିଂ ସ୍କେଲରେ 3.0 3.04 କୁ 3 ଏମାନେ ନେଇଛି ଆଣ୍ଡ ହାଇଡ୍ରୋଜେନ 2.2 ଠିକ୍ ଅଛି
3.16
ଆଁ
3.16
କୋଉଥିରେ ଦେଇଛି
ସେଇ ସବୁ କ୍ଲୋରିନ୍
ହଁ କ୍ଲୋରିନ୍ର ନା
ଆଜ୍ଞା
ଓ
ସାର୍
ସରି 3.16 3.16 ସମସ୍ତେ ଦଉଛନ୍ତି ମୁଁ ବି ଦେଇଛି 3.2 ପାଖାପାଖି ଦେଇଛି କିନ୍ତୁ ଆମେ 3 ନେଇଯାଇଛେ 3.16 ଯଦି ସେ ଅଙ୍କରେ ଦେଇଥିବ ତାହେଲେ ତ ଆହୁରି ବଢ଼ିଆ ବାହାରିବ କିନ୍ତୁ ତମେ କ୍ୟାଲକୁଲେସନ ମେଥଡ ବୁଝିଲ ତ ଆଁ
ଆଜ୍ଞା ସାର୍
ସେଟା
ଆଜ୍ଞା
କହିବ
ସାର୍
ୟେସ୍ ସାର୍
that finishes and ଏଇଟା ତମକୁ ଲେଖିବାକୁ ପଡିବ already ଆମେ discuss କରିଛେ what are the factors which influence electronegativity of elements ଗୋଟେ ହେଲା ENC ଆମେ ଦେଖିଲେ ଯେତେ ENC ବଢିବ in a period ENC ବଢି ବଢି ଚାଲେ so electronegativity ବଢି ବଢି ଚାଲେ directly proportional to ENC size of the valence cell ତଳକୁ ତଳକୁ ହେଲେ size ବଢି ବଢି ଚାଲେ electronegativity କମେ ଯଦିଓ ENC ସମାନ ରହେ କିନ୍ତୁ ସାଇଜ ବଢିଲେ ଇଲେକ୍ଟ୍ରନ୍ ଗିଳିବାର ଟେଣ୍ଡେନ୍ସି ଆଣ୍ଡ ଇଲେକ୍ଟ୍ରନ୍ ଟାଣିବାର ଟେଣ୍ଡେନ୍ସି ବହୁତ କମିଯାଏ ଅକ୍ସିଡେସନ ଷ୍ଟେଟ୍ ଅଫ ସେଣ୍ଟ୍ରାଲ ଆଟମ୍ ମୁଁ ତ ଏକଥା ବି କହିଛି ଯେ ସଲଫର ସବୁବେଳେ ଯେ ଯାହା ଲେଖା ହେଇଛି ସେଇଆ ତା ନୁହେଁ ସଲଫରର ସ୍ଲାଇଟ୍ ଚେଞ୍ଜ ବି ହବ depending on oxidation state more the oxidation state greater is the electronegativity SF6 ଆଉ SCl2 এটা +6 ରେ ଅଛି ଏଟା +2 ରେ ଅଛି ତେଣୁ their electronegativities are slightly very different maybe in the second place of decimal maybe in the first place of decimal but they will be different ଯେତେ ଆମେ ପଢିବା ଫାଜାନ୍ସ ରୁଲ୍ ସେଥିରେ ପଢିବା କେମିକାଲ ବଣ୍ଡରେ पोलराइजिंग पावर जिते बढ़िबो सेते सेते इलेक्ट्रॉन टाणीबार प्रवृत्ति बढ़िबो सल्फर हैज हाँ सेमती मैंगनीज मैंगनस ऑक्साइड मैंगनिक मैंगनीज 2 ऑक्साइड मैंगनीज 3 ऑक्साइड मैंगनीज 4 ऑक्साइड मैंगनीज 7 ऑक्साइड एथिरे इलेक्ट्रोनेगेटिविटी मैंगनीज स्लाइट बढ़ी बढ़ी जीवो ता छड़ा हाइब्रिडाइजेशन ऑफ कार्बन मोर इज द परसेंटेज ऑफ S character S has no angular node and more penetrating in nature therefore S character बढ़िला माने इलेक्ट्रोनेगेटिविटी बढ़िबो कारण से टाणिबो से बॉन्ड रो जो हाइब्रिड ऑर्बिटल आमे पढ़िबा S character जदि बढ़िबो तार हाइब्रिडाइजेशन अछि sp3 sp2 dsp2 सो S character बढ़िला माने से कार्बन रो से पर्टिकुलर कंपाउंड रे इलेक्ट्रोनेगेटिविटी अधिका more the percentage of S character greater is the electronegativity example होची धर इथेन सही कार्बन एथिरे sp3 hybridized 25% S character एथिरे किंतु sp2 33.33 S character एटा होची acetylene which is sp hybridization 50% s character. So sei carbon ro electronegativity eithre maximum maybe eta jodi 2.5 hela ki 6 hela eta 2.5 eta 2.4, so there will be difference. So eta tame nije khatare lekhibo. So there is definitely some difference between electron affinity and electronegativity. This is just a relative term taking fluorine as the maximum, and this is the energy term. They are expected to be parallel, but there are many anomalies, particularly in the p block. You will find the trends are different. Electronegativity decreases, and there is some anomaly in the middle row. But in the electron affinity, the third period element has the higher than the second period element. Fluorine is the most electronegative, but chlorine has the highest electron affinity. So this finishes our electronegativity program. Then we shall be talking of this melting point and boiling point. I think today we shall be taking up the oxidation state. That will be more interesting for the remaining 30 minutes. Oxidation state of elements. And definitely we'll be having one more session for melting point, boiling point, and densities. Yes, there is a particular pattern, particular trend along groups, periods, transition groups, transition periods. So we have to. But let's take up oxidation states of elements. Now S block, you have to write at home. Whatever we'll discuss, you have to write point by point, line by line from this file that I will send you. S block, there is no variable oxidation state. Group 1 plus 1, group 2 plus 2. Only one oxidation state, no variable valency. Group 13 in the P block starts variable valency. Maximum is plus 3 according to the old group name 3A, IIIA. So that is the maximum valency, plus 3. And the minimum is plus 1. Why it is so, I will tell you just now. 14 to 17, maximum hochi group number according to old convention. For example, group 14, IV A thila plus 4. And 15 ra plus 5, 16 ra plus 6, 17 ra plus 7. Minimum hochi 8 minus the group number with a minus sign. For example, group 14 ra 8 minus 4, 4 minus minus 4. So group 14 elements, carbon can say lose 4 electrons. It's not going to lose actually. It can have covalent bond where carbon is less electronegative. The oxidation state can be plus 4. It cannot give a ion like 4 plus. It's not possible. So the oxidation state can be plus 4 if it is losing or is less electronegative and sharing with others more electronegative elements. And the minimum can be, maximum will be plus 4, minimum will be minus 4. Because if carbon is more electronegative, like magnesium carbide, calcium, not that, beryllium carbide, aluminum carbide, where carbon is in the minus 4 state, there it is really an ion and it is taking 4 electrons and it is 4 minus. Of course, there is some covalent character. Fajan's rule will study that ionic compounds also have some covalent character. Polar covalent bonds have ionic character. We already know, and crude rule we have learned how to find in a particular polar bond what is the percentage of ionic character. Similarly, we'll be knowing that relatively which one has a higher covalent character, which one has a lower covalent character in ionic compounds. And similarly, for group 15, it is plus 5, maximum is minus 3. Group 16, it is plus 6, minus 2. Group 17, plus 7, minus 1. By gaining 1 electron, it will be octet. By losing 7 electrons, it cannot lose, but If you talk of chlorine heptoxide, Cl2O7, then chlorine is less electronegative 3 and oxygen is 3.5. So chlorine will have a positive oxidation state, is 3 point, that will be plus 7. So it can go to plus 7 and the minimum is minus 1. These things you know. Group 18, he used to say 0. Nowadays, no. Group 18, though noble gases, the maximum oxidation state is the group number. I am not the group number. It was 0, called it was group 0 earlier. Now it is group 18. It is plus 8 because octet, excepting helium, which has a duplet configuration, others will go to the maximum plus 8 by sharing all the 8 electrons present in their valence shell. Helium is only plus 2. Others can go up to, helium compounds have been also been internoble gas, helium, neonide, mercury halide, tungsten halide, sodium halide. So helium compounds have been synthesized. But oxidation number for such compounds cannot be assigned. But there are many, we'll study for xenon compounds. You can assign xenon trioxide, xenon, in the pergenate ion, it is plus 8. In pergenate ion, it is plus 8. You will see later in xenon compounds. So it can go up to maximum plus 8 because it is octet, excepting helium. So group 1 plus 1, excepting hydrogen, which is present in group 1 as well as in group 17. So therefore, it has plus 1, having a resemblance with alkali metals, although it is not a metal. Minus 1, resemblance with halogens. So therefore, agaromausis, agaropiusis. Group 2, only 1 plus 2. Group 3 plus 1. I'll tell you. Aluminium, rasana 3. Kintu thallium ro dita achi. TLCl3 achi, TLCl achi. We'll see that inert pair effect today. Why in the P block there is variation, there is variable oxidation state. That one. Similarly, group 14, maximum plus 4, minimum minus 4. Aluminium carbide. And mojire gote plus 2 bhi achi. That is the stannous chloride, plumbous oxide, plus 2 bhi achi. Carbon has many variable oxidation state besides plus 2. It can be minus 1 also, acetylide. Oxidation state can be minus 1. Calcium, the strontium, they give carbide, which is a different type of carbide, acetylide. This carbon is minus 1. We'll see that. Group 15, maximum plus 5 and minimum minus 3 in ammonia, magnesium nitride, aluminum phosphide, minus 3. But there is intermediate also. There is also plus 3, like arsenous oxide, bismuth trichloride, or simply bismuth 3 chloride. You can say bismuth 3 chloride. Also, there is a bismuth 5 chloride, which is unstable, that we shall study. Why 3, 5? Why 3, 1 in thallium? Why is 4, 2 and all that will be knowing. Just by opening the box, we can know the electronic configuration of the valence shell. Group 16 plus 6 and minus 2 is the minimum, like S2S, MgO, MgSe. But in between there will be plus 2 and plus 4. There are so many examples of plus 2, selenium dibromide, or you can say selenium 2 bromide, tellurium 2 chloride, polonium 2 chloride, plus 4 SO2, SeCl4. So there are intermediate plus 2 and plus 4 besides max and min. Oxygen has other oxidation state also. Minus 1 in peroxide, minus half in superoxide. It should be minus half. Oh, 80 rohi and plus 2 in oxygen difluoride, plus 1 in dioxygen difluoride. That you know. P block ଚାଲିଛି କଣ୍ଟିନ୍ୟୁ କରୁଛି ଆମେ 16 17 ରେ ସେମିତି ପ୍ଲସ୍ 7 in periodic acid dichlorine heptoxide. Minimum hoji minus 1 HCl NaBr, and in between there will be plus 1, plus 3, plus 5. Plus 1 dichlorine monoxide, plus 3 it is chlorous acid, +5 it is iodic acid. One example has been given in each case, but there are multiple as you study the individual groups. Group 18 I was saying, +8 is maximum pergenate ion or xenon tetroxide. Pergenate ion is XeO6 4 minus. You can calculate xenon has oxidation state of +8. On other intermediate state can be +2, +4, +6, and max is +8. Mean is 0. You don't write 0 because 0 means in uncombined state it is 0. So we have not written them. Now the question of D block is very, very important. You have to write down everything in your copy. Because we are running short of time, at 6:30, we have to complete this aspect. Now see, I'll be showing you an interesting thing here. Looks like a triangle. Scandium group, particularly scandium, yttrium, lanthanum, these three belonging to the scandium, and actinium. They exhibit only one state, particularly scandium +3. No variable oxidation state, and hence scandium is not a true transition metal. A transition metal is that metal or that element which shows an incomplete D subcell in any of the compounds in aqueous solution. Scandium doesn't have any compound in aqueous solution where you can find +2 state. Only +3. 4s2 will go and immediately the 3d1 will jump. The moment 4s2 jump, 3d1 will jump. So it will be +3. The reason we'll be knowing later why it is happening. But aste aste dekho oxidation state बढ़िला. 4s2 गले +2, देन गोटे गोटे गुळु गुळु हेकरी 3d गोटे गले +3, एम 3d2 सेमानकर अछि समस्त कर nd2 ns2 n-1 d, sorry, ns2 n-1 d2. So ns2 गले +2, से दीटा को एट ए टाइम जिबे आ तापर गोटे गोटे गुळु गुळु करी गले +3 +4. देन भैनेडियम ग्रुप रे आउरी बड़ी 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 गला जेतेटा इलेक्ट्रॉन अधिका हला सेटा होची n-1 d3. तेणु +2, देन गुळु करी गला गोटे +3 +4 +5. रेड जोटा कही मोस्ट कॉमन भैनेडियम रो 3 and 5, भैनेडियम नायोबियम टैंटालम जो तीनटा अछि 3 and 5 they are common, but it can have +2 and +4, they are there. क्रोमियम रे आउ गोटे बढ़ी गला but it is 4s1 3d5, तेणु क्रोमियम रो +1 स्टेट भी अछि क्रोमियम रो. टंगस्टेन रो नाही, मोलिब्डेनम रो अछि because tungsten has no such anomaly. It is 6s2, 4f14, and then 5d4. So +1 bhi paribo, then +2 +3 +4, and ultimately all the d electrons will vanish. All the 5 d electrons will vanish. So same thing, manganese ra madhya 5, 4s2 3d5. So yara +1 nahi, +2 or and +3 +4 +5 +6 +7, out of which +2 +4 and +7 are common. Others are there also, like manganate ion, it is +6. Manganese 3 oxide, it is +3. +5 is very uncommon, but it's possible. So it goes up to maximum +7 in group 7. Manganese is group 7, maximum is +7. D5, ns2 n-1 d5. Then pairing will start. Hunt, then poly will start. Then they will show increasing resistance to participate in bonding. May it be covalent bonding. So tapare dhire dhire kamila iron +6. +2 ru +6. Common hela ferrospheric with iron 2, iron 3. Same thing cobalt group re auri gote kamila. Pairing jete jete houthibo sete maximum oxidation state kamuthibo +5, but cobalt group ro max mane common hochi +2 +3. Nickel ro aure gote kamila. Nickel only one, it is very common. +3 and +4 are very unstable and very strong oxidants. They switch back to +2 easily. Copper auri gote kamila, +3 bhitar achi but it's very strong oxidant and it comes back to +2 easily, but it is there. So गुटी गुटी लेखा कमी 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 एंड एठी कपर जेहेतु कपर एंटायर ग्रुप सारा +1 भी अच्छी कहीं NS1 N-1 D10 तेणु समस्त +1 भी अच्छी एटा खाली क्रोमियम मोलिब्डेनम अच्छी एटा समस्त अच्छी अरस अरिक सिल्वर अच्छी किंतु मोस्ट कॉमन होची +1 +2 एंड +3 आर वेरी अनस्टेबल फॉर सिल्वर गोल्ड किंतु अरस अच्छी अरिक अच्छी एंड +2 इज अनस्टेबल कपर ये जोड़ी अच्छी क्यूप्रस एंड क्यूप्रिक +3 इज वेरी अनस्टेबल बट जिंक ग्रुपटा कौन सी वेरिएबल ऑक्सीडेशन ना जिंक कैडमियम मर्क्यूरी दे शो ओनली वन आई मीन मर्क्यूरिक अच्छी बट दे डोंट इन्वॉल्व द d electrons. So according to the definition, mercury is not a true transition metal. All the three, zinc, cadmium, mercury, they are not true transition metals. Although they belong to the D block, they do not have any compound having an incomplete D subcell. So zinc ra +2, cadmium ra madhya +2, केवल mercury ra +1 and +2, but that is involving 6s1 and 6s2. किंतु गोटे एक्सेप्शन अच्छी द मैक्सिमम ऑक्सीडेशन स्टेट इन द एंटायर D block is the iron group, not iron. Iron can go up to +6, but the tolo dita, ruthenium and osmium, they can go up to +8. Particularly osmium tetroxide, where +8 state is for osmium is highly stable. So highest होची group 8 रे किंतु आयरन रो मैक्सिमम +6 पेयरिंग आरंभ हेलानी किंतु तळकु गले टिके ऑल दी जो पेयर्ड हेची से मध्य पार्टिसिपेट करिवो जे पेयर्ड हेइथिला भी सी भी पार्टिसिपेट करिवो तळकु गले जेते तळकु जीवो रुथेनियम रे टिके कम रुथेनियम टेट्रोक्साइड इज लिटिल लेस स्टेबल बट ऑस्मियम टेट्रोक्साइड इज हाईली स्टेबल विल नोट द रीजन व्हाई लेटर सो एई जिंसटा को तुमको ड्रॉ करियो पड़ियो ड्रॉ कर दो कि टिके ना घरे करियो बाबा बाबा माने ड्रॉ करियो ना घरे करियो गोटे एग्जांपल लिखी आयरन रो +6 आयरन ट्राइऑक्साइड नॉट फेरिक ऑक्साइड आयरन ट्राइऑक्साइड इज आयरन 6 ऑक्साइड अरे बाबा माने लिखुच ना घरे लिखियो बोली कुह अरे अच्छो कि ना
लिखुच
लिखुच लिखिदियो कारण मोर इंटरेस्ट होची इनर्ट पेयर इफेक्ट पढ़िया भाई सेटा होची तार एंड एटा सब लिखिबो घरे ट्रांजिशन मेटल मानकर ऑक्सीडेशन स्टेट केमती बढ़ी बढ़ी जाए मैक्सिमम ऑक्सीडेशन स्टेट आउ वेरिएबिलिटी मध्ये बढ़ी बढ़ी जाए मैंगनीज ग्रुप पर्यंत ग्रुप 7 +7 तापरठू गुटी 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 कमिला आयरन +6 कोबाल्ट ग्रुप रो +5 निकेल ग्रुप रो +4 कपर ग्रुप रो +3 जिंक ग्रुप रो किछि नाही +2 मैक्स केवल मर्क्यूरी रो +1 +2 अछि मु जहा लिखिछि गोटे टेबल गोटे ट्रायंगल भलिया देखा जाउछि Hello, those who are watching in the video and following us regularly for them. Yes, while I teach to two of the best students of our state, I feel appropriate to record it and share with all good students who are in Odisha, particularly because mostly I am using English deliberately, but yes, sometimes if I find that they cannot understand, then I don't mate ओडिया रे कहिबारे कौनसी द्विविधा नहीं
Yes, sir.
बोलला
आज्ञा सर
Yes, sir.
now see এটা অলরেডি ମୁଁ डिस्कस କରିଛି ସେଟା অলরেডি डिस्कस कर सारे lanthanides and actinides विषय में पर डिटेल डिस्कशन करिवा कॉमन lanthanides रो कॉमन होची +3 अनकॉमन होची +2 एंड +4 actinides मानकर मैक्सिमम जेमती गला मैंगनीज पर्यंत गला सेमती actinides मानकर जीव +7 पर्यंत नेपटूनियम एंड प्लूटोनियम पर्यंत देयर आफ्टर इट विल डिक्रीज देन +3 is the common oxidation state for all but it increases up to +7 in neptunium and plutonium. About this, we shall be studying later in details, I mean class 12. Now the inert pair effect. I am just explaining you in my, that will be the end of our program. We are left with, this is 23. So let me write down, this is an effect in the P block. In the P block, not in any other block. As we go down in any group, the higher oxidation state, becomes less stable. Conversely, the lower oxidation state too less. অর্থটা বুঝেবি becomes more and more stable. ତା ରିଜନଟା ମୁଁ କହୁଛି ଏଇ ଇନର୍ଟ ପେୟାର ଇଫେକ୍ଟର ରିଜନ ହେଲା କ'ଣ it is because the ns electron pair gradually becomes more inert and show reluctance to participate in bonding. तार पुणी रीजन कौन? This is again because the bond energy evolved cannot adequately compensate for the excitation energy for ns electron एतिकी एक्साइटेशन एनर्जी फॉर एनएस इलेक्ट्रॉन देख मु गोटे एग्जांपल दूची कार्बन फैमिली रे आग मु दूची कार्बन फैमिली देन बोरॉन फैमिली देबी देखो कार्बन फैमिली रो NH2 NP2 कार्बन रो 2s2 2p2 सिलिकॉन रो 3s2 3p2 इन जनरल एटा हाउस तंगर ग्राउंड स्टेट एथरे सब एटा ग्राउंड स्टेट एथरे सब एक्साइटेड स्टेट रे ही बॉन्डिंग हुए ये एनपी रो एनर्जी अधिका तेणु से माने आग लॉस हेबे बा यूज हेबे कोवेलेंट बॉन्डिंग रे ये रहिबो यस तार आ गोटे एक्साइटेड स्टेट भी अछि ये डिया मारिबो एनर्जी डिफरेंस अच्छी एनएस और एनपी भितर एनर्जी काफी अधिक अच्छी नॉट दैट n-1 डी और एनएस भितर जमी एनर्जी गैपटा कम सेमती एनएस एनपी भितर एनर्जी गैपटा कम नहीं एप्रिशिएबल एनर्जी डिफरेंस अच्छी बिटवीन दी एटा हला एक्साइटेड स्टेट एणिकी आम ये लिखा जीएस ये लिखा इएस सो ये जो एनर्जी दरकार एक्साइटेशन एनर्जी दरकार सेटा किए दिए ना बॉन्ड हेला परे जो एनर्जी बाहर कहते बॉन्ड एनर्जी सेटा प्रोवाइड करे पिला पचारे केमती आग बॉन्ड फॉर्मेशन हम पर एक्साइटेशन हम आगे केमती सेटा संभव संभव अच्छी सबुथ गोटे एक्टिवेशन एनर्जी अच्छी काइनेटिक्स रे पढ़ा हम 12th क्लास रे आग से सराउंडिंग रू नहीं जाए ताकू प्रथम एक्टिवेट करने सराउंडिंग रू नहीं जाए किंतु परवर्ती काल में माछ तेल रे माछ भजा हवा पड़ो तेणु सेटा दब किए ना जो बॉन्ड एनर्जी तैयारी होची जो बॉन्ड होची तो एनर्जी बाहर तापर आउ दरकार नहीं एक्टिवेट करने जस्ट अल्प टिके एनर्जी दरकार से सराउंडिंग नहीं जीव सब बड़े सराउंडिंग दे पारिबनी तेणु यार दीटा स्टेट अच्छी एटा यूज हेले +2 स्टेट ए सबुतक यूज हेले +4 स्टेट बॉन्डिंग रे कोवेलेंट बॉन्डिंग रे गोटे अनपेयर्ड इलेक्ट्रॉन यार तार आउ गोटे अनपेयर्ड इलेक्ट्रॉन दरकार लोन पेयर दरकार नेटिव बॉन्ड पाई किंतु नॉर्मल कोवेलेंट बॉन्ड पाई मु प्योर कथा कहूनी नॉर्मल कोवेलेंट बॉन्ड पाई यार गोटे तार गोटे तापर देखा जाव आर एस और पी माने मिसी जाती मिसी गोटे हाइब्रिड ऑर्बिटल तैयारी करती आई केतबेले सबुतक मिसीगले sp3 केतबेले तीनटा मिसले sp2 केवल दीटा मिसले sp से कथाटा आमे परे पढ़िबा वी आर नॉट इंटरेस्टेड इन दैट तेणु जितेबले आर +2 +4 स्टेट अच्छी आराम रे ए कार्बनटा एते छोट आस्ते आस्ते बड़ बड़ होगी गले मु कार्बन फैमिली कथा कहूँ आस्ते आस्ते बड़ लेड वर्ग आसला बेलू एत बड़ हो जाऊँगी जे लेड्रे मध्य से ही अवस्था से जीवाक चाहूनी लेड्रे मध्य सैया सी ग्राउंड स्टेट रहा चाहूँगी यहाँ हूँ 6s2 6p2 लेड्र एटा इनट बहुत हो गला जीवाक चाहूनी मोस्ट इनट तलू तलू जिते जीव साइज से बढ़ साइज बढ़िले जो बॉन्ड एनर्जी आउ जी आसो जी क्लोरीन लागू कि जी लागू क्लोरीन लागू कि जी लागू बॉन्ड एनर्जी कमिले सी यहीटा को एक्साइटेशन जी एनर्जी दरकार सी दे पार ना बॉन्ड एनर्जी एत कमिज जे से 6 इलेक्ट्रॉन गुड़ाक माने मुझे एनएस इलेक्ट्रॉन रो इंक्रीजिंग रेजिस्टेंस रिलक्टेंस टू पार्टिसिपेट आज गो डाउन द ग्रुप से तलू को आसला बेलू लेड आसला बेलू +2 इज स्टेबल +4 इज अनस्टेबल मु कौन लिखिली आज यू गो डाउन द ग्रुप द हायर ऑक्सीडेशन स्टेट इज स्टेबल लोअर ऑक्सीडेशन हायर ऑक्सीडेशन स्टेट इज अनस्टेबल becomes more and more unstable lower oxidation state too less becomes more and more stable because एइथिरे हायर ऑक्सीडेशन स्टेट रे एनएस इलेक्ट्रॉन टाको पार्टिसिपेट करिया पड़िबो सी अनपेयरिंग हबा को पड़िबो एक्साइट करिया को पड़िबो एनर्जी ताको नबा को पड़िबो एक्साइटेशन एनर्जी सेटा दबो किए माछ तेल तेल तो कम बाहरुची आ माछ भजा हबो केमती हेई परिबोनी जहाँ हम बहुत कष्ट मस्ट हम नॉट दैट +4 स्टेट नाई एग्जांपल दूची PbO2 अच्छी +4 इज हाईली अनस्टेबल एंड इज ए स्ट्रॉन्ग ऑक्सीडेंट तैयारी करदेव जदि बेसी समय रखनी सांगे सांगे यूज करिया पड़ो इज ए स्ट्रॉन्ग ऑक्सीडेंट समस्त को ऑक्सीडाइज करदेव से सेमती PbCl4 डज नॉट एग्जिस्ट एट रूम टेम्परेचर रूम टेम्परेचर रे से PbCl4 भांगी जीव इंटू PbCl2 एंड क्लोरीन भांगी डज नॉट एग्जिस्ट एट रूम टेम्परेचर ताकू तुम रखा चाहूँ 0 डिग्री सेल्सियस को नियो किसी समय रही सेमती आमे जदि जीवा ग्रुप 3 को बा 13 को देखिबा बोरोन फैमिली रे NH2 NP1 तेणु तार मैक्सिमम 1 एटा पार्टिसिपेट करिवा +1 टा कॉमन +3 टा अनकॉमन कारण एटा होची ग्राउंड स्टेट तार एक्साइटेड स्टेट एटिक जीव गले 3टा अनपेयर्ड इलेक्ट्रॉन आसीबो सो एटा +1 देखेबो एटा +3 देखेबो किंतु ग्रेजुअली गो डाउन द ग्रुप तुम पहुंचला बेलू थैलियम रे पहुंचला बेलू से 6s 6s1 6s2 6p2 ଆଉ ତାର 4f14 ନା 5d ଲେଖୁନି ମୁଁ ଭ୍ୟାଲେନ୍ସ ସେଲ୍ କଥା ଲେଖୁଛି 5f1 ତେଣୁ ଇଏ ଯିବାକୁ ଚାହିଁବ ନାହିଁ ଦିସ୍ ଟୁ ୱିଲ୍ ବି ଇନଟ୍ ତେଣୁ ଇଏ ଯିବା ପାଇଁ ଚାହିଁବ ନାହିଁ ତେଣୁ +1 ଇଜ୍ କମନ୍ ଥାଲିୟମ୍ ତାର ଏକ୍ସାମ୍ପଲ୍ ହେଉଛି ଥାଲିୟମ୍ କ୍ଲୋରାଇଡ୍ ଇଜ୍ ଷ୍ଟେବଲ୍ ଥାଲିୟମ୍ ଯିବାକୁ ଥାଲିୟମ୍ର ଟ୍ରାଇକ୍ଲୋରାଇଡ୍ ଇଜ୍ ଅନଷ୍ଟେବଲ୍ ଆଟ୍ ରୁମ୍ ଟେମ୍ପରେଚର but thorium chloride monochloride is stable ତାକୁ କହନ୍ତି ଇନର୍ଟ ପେୟାର ଏଫେକ୍ଟ NS ଇଲେକ୍ଟ୍ରନଟା ତଳକୁ ତଳକୁ ଗଲେ ଷ୍ଟେବଲ୍ ହେଇଯିବ ସେମିତି ଗ୍ରୁପ ଏଇଟା ଲାଷ୍ଟ ଗ୍ରୁପ 15ର ଆମେ ନାଇଟ୍ରୋଜେନ୍ ଫ୍ୟାମିଲିର ହେଲା NS2NP3 ତାର ଦେଖ କେତେଟା ମୁଁ କାହିଁକି 2 ଲେସ୍ କହିଲି ତମେ ଜାଣିପାରିବ ହୁଣ୍ଡ ସୋ ଏଇଟା +3 ଷ୍ଟେଟ୍ ଦେଖେଇଦେଲା ଏଇଟା ଲୋୟର 2 ଲେସ୍ ତେଣୁ ଏଇଠି ଯଦିଓ ନାଇଟ୍ରୋଜେନ୍ ଦେଖି ପାରିବନି यार ND अच्छी भैकेंट केवल फॉस्फोरस रु एटा संभव नाइट्रोजन रे पेंटा कोवेलेंट केबे ही परिबनी और जदिओ ऑक्सीडेशन स्टेट +5 हे परिबा बाय यूजिंग ए डेटिव बॉन्ड करिक +5 स्टेट को देखै परिबो बट पेंटा कोवेलेंट देखै परिबनी NCl5 डज नॉट एग्जिस्ट बिकॉज इट डजंट हैव ए वैकेंट डी ऑर्बिटल सेटा हम पढिबा ये रे तो एठी फॉस्फोरस रे पर्टिकुलरली आमे पाई परिबा एठी जाई परिबो so that we can have +5 state. It is the highest state. This is GS, this is the excited state. So हमें 5टा इलेक्ट्रॉन पाइलेनी 5टा देई परिबो PCl5 हेई परिबो but as you go down the group ये जीवा को चाहिबोनी काई ना बॉन्ड एनर्जी कमी जीवो माछ तेल कमी जीवो so bismuth रो pentachloride is unstable at room temperature rather 2 less এইটা পার্টিসিপেট ন কলে 2 লেস হচ্ছে কি +3 তেণু মু জানিকি কহিলি লোয়রটা হচ্ছে হাইয়েস্ট তো হাইয়েস্ট অল 2 লেস সেটা হচ্ছে মোর স্টেবল হয়ে যাব এইটা পার্টিসিপেট ন কলে অক্সিডেশন স্টেট উইল বি 2 লেস দ্যান হোয়াট ইজ দি ম্যাক্সিমাম রাইট সো দ্যাট উইল বি মোর স্টেবল সো বিসমথ ইজ ভেরি স্টেবল সেমতি বিসমথ পেন্টক্সাইড ডজ নট is unstable bismuth pentoxide is unstable. Same inert pair effect is the reason. While bismuth trioxide is stable. So this finishes our today's program. You will study from the this thing, but recent research has revealed the inert pair effect is not due to the bond energy not compensating for the excitation energy. That is not the real reason why it is happening. It is due to some other thing which is called relativistic contraction effect. The 6s electron becomes so tight because of the relativistic effect that they don't like. So the real reason lies behind relativistic contraction effect, which is not told to +2 students, but I will be sounding you explanation when I'm giving. You will just write one by one. I have already explained everything. But I have here have written relativistic effect of 6s electron pair for thallium, lead, bismuth, polonium. That is the also one of the main reasons behind the inert pair effect. কিন্তু ମୁଁ bond energy କଥା ଲେଖି ଦେଇଛି. So that is the end of today's program. Bye bye.
Thank you, sir.
Thank you, sir.